Well, that's a very good question. Why do we have weather? Well, let's see if we can figure it out over the next few minutes here. Stay tuned. So why do we have the weather? Just think about it. Why is there wind? Why does it blow from one direction one day and another the next? Why is it rainy one day and dry the next? How come it's cold in the winter? How can we have hail in the summer? What causes snow and freezing rain? If we were to pick one term to help explain why we have weather, what do you think would be a good word? Wind? Sunshine? Snowstorms? Thunderstorms? You might pick heat or sun, but another good choice would be convection. Convection. Before we explain convection, let's see how it gets started. Atmospheric heating. Well, in order to have weather, we got to get the atmosphere warmed up. So how does the atmosphere get heated? The sun, of course, but not how you think. If the sun heated the atmosphere directly, the top would be the warmest because it's closest to the sun. What actually happens is that the sun's radiation strikes the Earth's surface and heats the surface. The atmosphere is resting on the ground. The air that is touching the ground gets heated. Now that's called conduction because it's touching it. This heated air becomes less dense and begins to rise because, as we all know, warm air rises. As it rises, cold air, which is more dense, sinks and touches the ground. Now this air gets warmed and it starts to rise. The warm air rises slowly higher and higher. As it keeps rising, it begins to cool and starts to sink back towards the ground where it can get warmed up all over again. So we got rising and falling, heating and cooling. Now this warm air that was rising, these are warm air molecules. Now these warm air molecules, they're bumping into other molecules of air that might be sinking. So as this warm air rises, it helps to warm some of the air that's cooling and dropping back down. So we've got a circulation of heat through the gases. Okay, the convection is the transfer of heat in gases or liquids. If you've ever boiled a pot of water on the stove, you'll see the air bubbles coming up from the bottom and rising up towards the top. Well, that's the heat rising, and if you look at the edge of the pan, out near the outside edges, you'll see how it's kind of circling back down. The cooler water is dropping back down. After the atmosphere gets warmed up by radiation and conduction, the heat's transferred throughout the atmosphere by convection. Since warmed air has more space between the molecules, it's less dense and it rises. Cooled air is more dense and tends to sink. In general, air near the equator tends to rise and air near the poles tends to sink. So if we look, we can pretend here's the equator, warm air is rising, and then as it rises up higher and higher, we got trade winds, we got the jet stream, we got various high altitude winds. The warm air is rising and it's circulating, and then as we get farther and farther away from the equator, the air begins to get colder and colder and sinks back down. Then it slowly flows along the Earth's surface back towards the equator, where it continues this rising and falling, this giant circulation on a globular scale. Take a look at this world map. If you look right through here, this is the equator. So you can see there's a band of clouds. Moisture rising, warm air rising, taking the moisture up into the air where it begins to cool off. And here we have cooler air drifting down from the polar areas. And also we've got the effect here, the Coriolis effect, because you can see this is kind of swirly. Okay, so the rising of the warm air and the sinking of the cool air. So take a look at these two world maps here. Notice again, right along the equator, we have this band of clouds. We have a thick band of clouds. Why do you think this band of clouds is there? Did you figure it out? Well, as we mentioned before, warm, moist air in the tropics rises because the equator is very warm, heats up that air, and it begins to rise up. Warm air has lots of spaces between the molecules, so it holds lots of water vapor, lots of moisture. As the warm air rises higher and higher above the ground, it begins to cool off. Cold air can hold less moisture because the molecules are closer together. So as the moist air rises, it cools off, which causes condensation, and as we know, condensation forms clouds. As we've learned earlier in other places, because of the Earth's rotation, wind currents and ocean currents rotate. They curve because of the Earth's rotation. This is called the Coriolis effect. In the northern hemisphere, these currents move in a clockwise direction. They curve in a clockwise direction. And in the southern hemisphere, they tend to curve in a counterclockwise direction. The Earth has a number of weather highways. When you combine the global winds, which are also called the prevailing winds, and we have three major global winds above the equator and three major ones below the equator. Along the equator itself, we have the trade winds. Then about 40-degree north latitude and 40-degree south latitude, we have the westerlies. And then up around 60-degree north and 60-degree south, we have the polar easterlies. So when you combine these global winds with the Coriolis effect, you can see how we have a circulation of air moving around the Earth. And this creates global weather highways. Because the United States is centered basically between 60 and 20-degree latitude, the westerlies come right across the middle of the United States, and most of our weather comes from the west. Looking at the weather map, what type of weather might we expect over the next few days? If we're right here in Georgia, looks like there might be a few showers tomorrow, and then next week there could be a major, or in a few days, there could be a major weather center with some rough weather. Okay, let's take a quick review here. All right, transfer of heat in liquids or gases. What did we say that was? Okay, convection. Number two, what kind of air is dense and tends to sink? It's heavy and dense. The molecules are very close together. Cold air, that's correct. The band of clouds found around the equator, caused by warm air rising and condensation. Number four, cold air holds more or less moisture than warm air. Of course, cold air holds less moisture because the air molecules are closer together and there's not enough space for the water molecules to be in there. Okay, I just realized this question is kind of messed up. All right, the way it should read, the Coriolis effect causes the air and water currents to be deflected which direction north of the equator? Would that be clockwise or counterclockwise? North of the equator, air and water currents are deflected in a clockwise direction. South of the equator, counterclockwise direction. Okay, so by now we've learned that weather moves around on these global highways, that warm air rises and cold air sinks. But why is it sunny one day and rainy the next? We need to learn about something called high pressure and low pressure. Let's take another look at the weather map. Okay, notice that there are blue H's and red L's on the map. There are also blue lines with spikes and red lines with half circles. Let's take a look and see if we can figure out what this is all about. Okay, high pressure areas. When cooler air sinks and is warmed, the air can hold more moisture. This usually means sunny skies. Winds tend to move clockwise around the high pressure center. So high pressure is usually represented by a blue H because high pressure is cool, dry air. And when we think of being cold, we think I'm turning blue because I'm so cold. So a blue H on a weather map stands for high pressure, which is cool, dry air. Okay, low pressure, which is a red L, when I think low pressure stands for warm, moist air. Because when I'm warm, I think I'm getting red hot. So red L's represent warm, moist air. Now, when warm air rises, it starts to cool off. Now, that warm air held a lot of moisture. As that warm air rises, the air begins to cool off. Since cool air can't hold as much moisture, it's going to make it start having condensation, and condensation leads to precipitation. So low pressure areas are usually associated with precipitation and stormy weather. So if you see a big blue H on a weather map over an area you live, you can expect fair weather, high pressure. If you see a big red L in your area, then there'll probably be stormy weather or rainy weather because that's a low pressure center. Hurricanes are massive low pressure centers, and we know how much rain and wind can come out of a hurricane. Okay, so we've learned what fronts are, high pressure and low pressure. But what generates these high pressure and low pressure? Well, air masses. Air masses are responsible for all of it. An air mass is a large body of air whose temperature and moisture are fairly similar throughout. Fronts are the boundaries that separate these different air masses. So an air mass is a huge body of air that has basically the same conditions. It might be warm and wet, or it might be cold and dry. And there are 4 different air masses that affect the weather of the United States. So the air masses, these 4 major air masses, first of all, let's do a little bit of what the terms are, the abbreviations. A small c stands for continental, which is dry air. Air masses that form over the land are going to be dry. M stands for maritime or ocean, which is going to be wet or moist air. A capital P stands for polar air, which we can figure is going to be cold air. And a capital T stands for tropical air, which is going to be warm air. All right, so to describe an air mass, we have to combine 2 letters. Okay, we've got small c, capital P, which means it's formed over the continent, and it's polar, so it's going to be cold and dry, stable. Small t, c, capital T, continental tropical, hot, dry air. Okay, continental is dry, tropical is warm. Maritime polar would be cold, wet air. Cold, wet, because maritime is over the ocean, and polar is going to be cold. Then maritime tropical is going to be warm and wet. Now, we're down here close to the Gulf of Mexico. Being where we are, affected by the Gulf of Mexico and the Gulf Stream, most of our weather is going to be affected by a maritime tropical air mass. So this map shows the air masses that affect the major regions of the United States. All right, as we said, down here in the southeast where we are, good old Georgia, we got air currents that are affected by the Gulf Coast, the Gulf Stream, and down here by the Gulf Coast. Since this is warm water down here, it's going to be maritime, and since we're close to the equator, it's going to be tropical. So our weather is greatly influenced by maritime tropical. If we look at here in New Mexico, Arizona, Nevada, the west out here, we think about deserts. Well, continental is going to be dry, tropical is going to be hot. Seattle, Washington, Oregon, Northern California, they get lots and lots and lots of rain. And because of that, what causes that is a maritime cold, they got cold, wet weather, maritime polar. And through Canada, they've got continental and polar, continental polar. So these are our major air masses that affect the weather in the United States. So as a summary, we have high pressure, low pressure, cold air, dry air, maritime, polar. All these different conditions combine to form the thing that we call weather.